We talked earlier about three variables that affect a gas: pressure, volume, and temperature. But there is another variable that we also bring in when we're talking about the conditions or state of a gas, which is the one we've been talking about since chapter 3, which is moles of the gas. Pressure, volume, temperature, and moles of a gas all play an integral role in affecting its properties. What we're going to do in this section is we're going to look at what are called the gas laws, which are relationships between those variables, how they relate to one another. What we find is that volume is directly related to all three of the other variables. So in this section, we're going to look at how they are related to volume. The first relationship we look at is called the pressure-volume relationship, otherwise known as Boyle's law. Boyle's law says that the volume of a fixed quantity of gas maintained at constant temperature is inversely proportional to the pressure. What that means is inversely proportional is if one goes up, the other goes down. If you have a balloon, if you increase the pressure on the outside of the balloon and you're squeezing on it, you're going to decrease the volume. Vice versa, if you put a balloon in a vacuum pump and you decrease the pressure pushing on it, you will increase the volume. They are inversely proportional. That's inverse. Proportional means by the same amount, meaning if you double the pressure on a balloon, you will cut the volume in half. If you quadruple the pressure on a balloon, the volume will be cut in 1/4. We can relate this using the Boyle's law equation, which is P1V1 equals P2V2. What I said earlier still holds here. In this calculation, these are sort of before and after conditions. You can figure out the change in things. P1 is the pressure that you're starting with, the initial pressure of gas. V1 is initial volume of the gas in atmospheres and in liters. P2 is the conditions that they change to. V2 are the conditions that they change to. And again, atmosphere and liters. Temperature and volume are also related. They're related via a law called Charles' law. Charles' law states that the volume of a fixed quantity of gas, again at constant pressure now, we're holding the pressure constant, is directly proportional to its absolute temperature. In other words, if you double the temperature of a gas, the volume of gas will double. If you quadruple the temperature of a gas, the volume of the gas will quadruple. We look at an equation that relates them to Charles' law and notice that it is slightly different. T1V2 equals T2V1. In this equation, T is measured in Kelvin, V is measured in liters. So again, we're looking at before and after conditions. What is the effect of changing the temperature or volume when pressure is held constant? The last relationship we look at is called Avogadro's law. And Avogadro's law relates the quantity of a gas to the volume. And this was actually pretty much common sense. Avogadro's law states that equal volumes of gases at same temperature and pressure contain equal numbers of molecules. So for example, if I have nitrogen and I have oxygen at the same conditions, at STP, 0 degrees Celsius, 1 atmosphere pressure, if the gases are containing the same volume, you have the same number of molecules. If we have the same number of molecules, we have the same number of moles. Now what Avogadro found was that at STP, at 0 degrees Celsius, and at 1 atmosphere pressure, when you had 22.4 liters of any gas, you had 1 mole of that gas. This is an extremely important number because it allows us to look at a molar relationship of gases then. Right? So this right here is probably one of the most important things we're going to see. 22.4 liters per mole at STP is called a molar volume. And we will use that very much like we did a molar mass. All right, so molar volume. For example, if I know I have a container of gas at STP and I have 44.8 liters, I know I have 2 moles. Knowing that I have 2 moles is extremely important to what I would need to calculate. So Avogadro's law states again that the volume of a gas maintained at constant temperature and pressure, if you're holding temperature and pressure the same, is directly proportional to the number of moles of a gas. In other words, if I want to increase the moles of gas into a container, I have to add more volume. So if I have a car tire and I want to put more moles of gas in there through a car pump, I'll pump up the car tire and make it have more volume.